Good day, sir. My name is Mariam Atahiru, a student of iconic Open University from Department of Public Health, studying postgraduate diploma in public health. I am here to present a term paper with the course title Nutrition in Health and Disease, course code PGDP 724. The question goes as biochemical pathways linking dietary components to the pathogenesis of cardiovascular disease and type 2 diabetes, implications of evidence-based dietary interventions. With admission number 24110085000021. We start with the introduction. Introduction plays a pivotal role in maintaining health and prevention disease. In particular, the dietary intake of micronutrients and micronutrients have been shown to directly influence the pathogenesis of cardiovascular disease and type 2 diabetes. These diseases share common pathophysiological features, including chronic inflammations, oxidative stress, and insulin resistance. Epidemiological studies have constantly demonstrated the strong correlation between dietary habits and the prevalence of metabolic syndrome components. Modern dietary patterns characterized by ultra-processed food, sweetened beverages, and low fiber intake have been shown to promote a pro-inflammatory metabolic environment. Biochemically, the metabolism of saturated fats leads to increased hepatic lipogenesis and elevated LDL cholesterol levels, a key contributor to atherogenesis. Role of nutrition: maintain health, that is to maintain good health, and prevent diseases from happening. Link dietary intake by eating very healthy to prevent CVD, that is cardiovascular disease, and T2DBM, that is type 2 diabetes. Pathogenesis of cardiovascular disease and type 2 diabetes, a biochemical overview of the two diseases. Cardiovascular disease and type 2 diabetes share overlapping pathophysiological features that arise from complex biochemical alterations. Both conditions originate from a background of insulin inflammations. At the core of their pathogenesis is the restoration of cardiovascular disease. Cardiovascular disease, which is the signaling of pathogenesis, is the disruption of the cellular signaling mechanisms and metabolic hemostasis driven by poor dietary intake. In this table, we show the overview of shared biochemical mechanisms of cardiovascular disease and type 2 diabetes, which is the insulin receptor inhibitions, mitochondrial ROS productions, the TRL4/NF-kB activations, and the formations, that is the cell formations. In this table, we'll see how the insulin resistance hyperglycemia leads to insulin receptor inhibitions, the type 2 diabetes, elevated free fatty acids, and chronic inflammations have also linked to mitochondrial ROS productions, and oxidative the oxidative stress also leads to form cell formation, because whenever there is a stress level problem or oxidative stress, it leads to form cell formations, which do ROS and inflammatory hydrogenesis promoting LDL oxidations. Microphages take up the carbonate receptors, which leads to cardiovascular disease outcomes. Saturated fats, we'll talk about the saturated fats and their biochemical role in disease pathogenesis. Here, the saturated fats are a major dietary component implicated in the pathogenesis of cardiovascular disease and type 2 diabetes, found predominantly in animal fats, because most of the saturated fats, that is the fats that accumulates to form the type 2 or that leads to all these diseases, almost comes from, or let's say 60% comes from or 7% comes from animal fat, full fat dietary products such as milk, cacao milk, and processed food. These fats adversely influence lipid profile, insulin sensitivity, and inflammatory signaling. The biochemical consistencies of high saturated fat intake are motivated and have a profound impact on metabolic health. In this diagram will show the biochemical effect of saturated fats, how saturated fat intake draws the TRL4 activations, the dark ceramide accumulations, and the NFK metabite inflammations, and the LDL-C elevations. In this diagram, we see how here you can see we see the chronic the cholesterol regulated uptake and the unregulated uptake of the saturated fats, and you can see how they interact with the enzymes in the body, with the cells, how they form the lysosomes, they form the pathogenesis, the phagocytosis, and how they modify the LDL, the CDT36, and how they change the saturated fat, how they extract, accumulate inflammations, and how they create the ceramide accumulations, and how they interact with one another in these cells. You can see how, if you can see here, we have the nucleus, we have the cholesterol storage, lipid droplets, we have the cholesterol efflux, we have the cholesterol excesses and the droplets, where we can see the saturated fat is having more interactions and accumulating all the fat or the enzymes in the cells. We refine sugar and insulin signaling distribution. In this page, we'll talk about how the refined sugar and insulin signaling to the disruptions of the cells in the body. Refined sugar, particularly glucose and fructose, are prevalent in sweetened beverages, desserts, and processed food. You can find the excess refined sugar more in the processed food, the beverages, and the sweetened beverages with the dessert. Their excessive consumption is closely linked to the onset of the onset and the progression of type 2 diabetes and cardiovascular disease through multiple biochemical disruptions, including hyperglycemia, insulin resistance, and oxidative stress and lipogenesis. In this we'll talk about the antioxidant and the oxidative stress modulations. As you can see, the oxidative stress plays a central role in the development and progression of cardiovascular disease. Whenever there is stress or the stress level is high, it always triggers the cardiovascular disease and type 2 diabetes. It arises when there is an imbalance between reactive oxygen species, that is the ROS production, and the body's antioxidant defense mechanisms. Diets rich in antioxidants, including vitamin C and E, polyphenols, carotenoids, and flavonoids, can counteract this oxidative burden, thereby modulating the key biochemical pathways associated with diabetes or the disease pathogenesis. We talk about the inflammatory pathways and metabolic regulations. Chronic low-grade inflammation is the hallmark of both cardiovascular disease and type 2 diabetes. Unlike acute inflammations, which is productive response, chronic metabolic inflammations or metaflammations is triggered by nutrition excess and persistent over time, contributing to tissue damage, insulin resistance, and vascular dysfunction. The initiative of inflammatory signaling in metabolic tissue such as the liver, the adipose, and the skeletal muscles is closely linked to the excess nutrition intake, particularly saturated fats and refined sugar. Integrating biochemical insights into dietary interventions, translating biochemical understanding into practical dietary strategies is very essential for preventing and managing cardiovascular disease and type 2 diabetes. With the recognition of metabolic dysregulation as a multifaceted process involving oxidative stress, lipid accumulations, insulin resistance, and chronic inflammation. Targeted nutritional interventions can modulate key pathways through restoring homeostasis. Dietary pattern or dietary patterns, rather than insulated nutrients, have emerged as more predictive of health outcomes. The Mediterranean food, that's the seafood, have rich in which are the beverages, legumes, whole grain, olive, and fish has rich in fruit, which and the rich yes, because fruit is rich, has constantly shown productive effects against cardiovascular and type 2 diabetes. With this conclusion, the intricate biochemical mechanisms underlying cardiovascular disease and type 2 diabetes mellitus are deeply influenced by dietary patterns. This review has examined the molecular pathways through which nutrients affect metabolic health, including oxidative stress level modulations, inflammation regulations, insulin signaling integrity, lipid metabolisms, and endothelial functions. The key processes such as the activations of TRL4, NFKP, and NLRP3 inflammations pathways, destruction of IRS1, the polypyralizations, and the mitochondrial functions underscores how nutrition excess, particularly from saturated fats and refined sugar, can dysregulate cellular homeostasis and promote disease process. So with this, I come to the end of my presentation. Thank you.